Right, so this episode we're going to get started on making our toolkit, and so similar to what I showed you in the last one, where we are using a library folder called lib. We are going to put inside the lib here the one that I've already created for you that you can download from Pastebin is this one. It's class turtletutorial.lua, and that goes in the computer library file, lib file folder here, and also the one that goes with it, which is the toolkit tutorial.lua. So I'll just show you those on Pastebin. So this is the first one, which is the toolkit tutorial, and it gives the link for the other library here. I'll put the things in the description here, and this is the class itself. Let's get those out the way. So starting with the class turtle tutorial here. So as before, when we did the adventure game one, we've got a class turtle here is the name of our table, and that is returned, if I can get to the bottom of this, made it slightly too big. Okay, and that's returned here as before. So that's what this whole file that I've got here for you is one that you can download and use as the basis for creating your own turtle object. So again, as before, we've got the stuff that creates the object, and we've got this new function here. Again, it passes in a name, which is not really required for the turtle, because we're not going to make multiple instances, multiple objects from this class. We're just going to create one instance of it and use that to control our turtle. So this was kind of irrelevant, but I put it in just to kind of show things how things work. So similar to the last time, we've now got a bunch of local variables which have all got the self dot in front of them. So these are variables that are used within the class. So most of them fairly obvious. The turtle's going to have an X, Y and Z coordinate, so I've set those by default to 0. Also the facing, as which direction it's facing in, so that in the Minecraft world is a number, and then the compass would be the text description of that facing. If I go back to Minecraft, escape from here and press F3, you'll see that I'm facing west, and then as I rotate north. So that's not actually this time listed as a number, but in older versions of Minecraft, Computercraft, etc., this would have shown as a number. So we'll just escape back from there, and so that's quite a useful thing to know, that the facing is a number which translates to the compass, which would be north, east, southwest, whatever. The equipped left and equipped right again refers to our turtle, whether we have got equipped on the right of this we've got a crafting table, and on the left we've got a diamond pickaxe. You can of course put different tools on here, and you can put in fact you could have, if you washed a pickaxe on this side and a sword on this, you can put a modem on for wireless communications. There's a whole bunch of different stuff you can add. So again, these are just set by default to empty. The place slot and place items, probably not required, but you'll be using them later, so I thought I'll leave them in there. And then the OS version is the operating system version. At the moment I'm running on Craft OS 1.8, which if we right click on the turtle, if I escape from that first of all, and we reboot, CraftOS 1.8 is what I'm currently using, so this again will return the version there. It might be useful in case you're trying to write your turtle class here for various versions of CraftOS. Some of them may not have some of the functions that are available in later versions, so you can write your code accordingly to compensate for that. So at the moment the only getter or setter I've got is this getter, which simply gets the turtle's name. So this gives you a kind of a basic class that you can download and start to use. Just returning to the tutorial Lure. Now this one looks a little more complex than you might expect, but again this is like the basic one that you can use to get started with your turtle. So again we've got a main function which runs up here. The couple of things I wanted to check when somebody places down a new turtle, particularly in creative mode, if you don't name the turtle and you hit it with your left button, it will destroy the turtle and the code that you've tried to save in it goes as well. So you must name it. So what I wanted to do was in this particular tutorial was to make sure that you hadn't in a hurry slapped down a turtle or wanted to get on with this and then forgot to name it. So the first function that this runs is one called check label. So if we go up to check label, let me just down that one there. Check label does if the operating system get computer label, which if you have named it, it will already have a name. So if you haven't, you've just banged it down, then there won't be a name and it will set it to the default toolkit and then print out the computer label set to there. So that's just a simple little function to just make sure that you have named your turtle. So once that's done, it will go to this one here. Now what we're looking for is, in order for this to work, the turtle class must be placed in a folder called libs, which again I'll just show you on here. So we've got, this is turtle number 8 as we've shown you before. We've got the toolkit tutorial file, and it's when it's running it will look for in lib class turtle tutorial. So in order to make sure that exists, I've just set up a little function here to make sure that is in there. So we're going to call next is the check libs, and we're going to look in the lib folder for a class called class turtle tutorial. So let's go back up to check libs. Now this is using some built-in Computercraft functions. FS is file system. So what we're going to check for in checklibs is to see whether the libdir, which is the folder name, which I've called lib, to see whether it exists. And the file name, of course, that we're checking for in this case is the menu file name, because we also need in our turtle to use the menu.lure that we used in 2 or 3 episodes back. So it's going to check for that, and the way it does that is it creates a local Boolean variable called file exists and sets it to false by default. Then it uses the file system exists. So we're now checking, is that directory libs, does it exist? So if it does exist, then that could of course be somebody has just created a file called lib, because again they're trying to break it. So this is idiot proofing yet again. So we're now checking if that libdir does exist, but lib is actually a file, not a folder. This checks whether it is a directory. If it's not a directory and it's a folder, then this will rename the folder to lib renamed, so that you're not deleting that file, even though it was deliberately put there to try and break your program. You're just renaming it, and then you're making a new directory called libs, which is what we want. So if it doesn't exist, then we're going to make it. So make the new directory called libdir, which of course we have said would be lib. It doesn't matter about capital letters because the Windows operating system doesn't care about capitals or lowercase. So, but by default we try and keep it to lowercase. So that's what that one does here. It checks whether we've got that folder lib. Then we're going to check whether the file that we want, which is the file name, which in this case we're looking for menu.lua, whether that file name exists. So we're using for that the file system combine, which is kind of a built-in function to bolt together the name of your directories and files with whatever, depending on what operating system you're in, either with the backslash as in Windows or the forward slash as in Unix, Linux and Mac, I believe, as well. So it's just checking whether that file exists. If it does exist, it's true. If it'll then set file exists to true, which if you remember was set to false by default, and then it'll return either true or false. So what we're doing with this one here is we're going to check whether menu.lua exists in the lib folder, and if it doesn't exist, it'll set this local variable, again a boolean one, to false. Next thing we're going to check is similarly if do continue is true, that means that menu exists. We're now going to check whether the class tutorial exists and whether the menu exists. So we're checking these two files to make sure they're in where they should be. So if they are both there, then do continue will be true, and then we can start running our program. So menu has been made a global variable up here. Now although it says local here, that means that these two variables, menu and capital T, which is going to be our turtle object, are local to this script, but that means that they are also available in all of these functions. If you have been playing with or using Python, Python has this weird thing where you declare a variable here in the side, kind of not inside any function or whatever. You'd think it would be available within any function. It isn't, unless you put some horrible thing in, which I believe is global, and then the variable name, which is absolutely horrible. So that's where Python really sucks. So luckily with Lua we don't need to do that. If you declare it in the main outside of all functions, it is available. These two are available everywhere, so it's local to this script. So that explains where that comes from. So we're now setting our menu as we did on our tutorial 2 or 3 episodes ago. We're getting the menu library in. Now you notice there that I've got this as lib.menu, and whereas down here I've used lib/. They work in exactly the same way. I believe in earlier versions of Computercraft you had to use the dot, whereas Lua generally would use the /, and so either of these work. It's entirely which one you use. So again we're using the .new, and I'm going to call this one tutorial turtle, and then just to test this out we're going to print my name is tgetName and print thank you for using Survival Toolkit, and that's pretty much it. So that's all this one does. So this entire program here just checks that we've got the computer label set, checks whether the libraries that you're going to use are in place, and if they're not in place it'll tell you add missing files and restart. So let's just run that to make sure that it all works. So we're going in here. If I do an ls, now the one we want to use is class, what was it called? Toolkit tutorial. So let's just get rid of all those. Right, so we want toolkit tutorial and then press enter, and it says my name is Tutorial Turtle, thank you for using Survival Toolkit. One thing you will notice is that the screen up here is still full of rubbish, so obviously the first thing we need to do is to fix that, because that is unbelievably annoying. So let's show you how to do that. So we're going to go over to the actual class here, class turtle, and we want to make a new function that will clear the terminal. So it doesn't matter where you put it. Let's put it under here. I like to put a bit of space in just so that they're all separated. So we're going to use the same format here. We're going to use the function class turtle, and then we're going to put dot clear and end. So that is where we're going to clear the screen of the turtle. And then, very important, you have to add on all new functions self. Now some of you who have already studied this would say, okay, but why don't you just put a colon here and then you don't need to put the self in? Yes, that's true, but when you're using one of these functions within the class itself, it can cause problems. So I personally prefer to stick with the original dot and self to make sure that functions used within functions here operate as they're supposed to. So in here, if you remember, we did this before. We used the terminal and its built-in clear function, and then the terminal set cursor pos, if I can find it, set, where are we? It's not there for some reason, never mind. Okay, set cursor pos, and then 1, 1. There we go. So our terminal will be cleared and the cursor brought back to the beginning. So we've added it now inside the turtle class with the class turtle dot and then the clear, and then we can now call it from our toolkit. So first thing we do is we create our turtle. Before we print out its name, we want to now clear the terminal. So this is where the capital T comes in, because I've just called T colon, not single dot, clear, and that should call the clear function. So let's save everything and we'll get that out of the way. So again, we've got a whole bunch of stuff up here. So if we put in toolkit tutorial, with luck it'll say my name is Tutorial Turtle, but it will clear the screen first. There we go, that's worked. So we've now cleared the screen. My name is Tutorial Turtle, thank you for using Survival Toolkit. In other words, our program is extremely short. It doesn't do very much, but it does work. So you can see now the basic thing that we're going to be doing is going to be adding a lot of things to our turtle class here to do various things. So we've cleared the terminal, which is great. So given that you want to use this as a kind of a toolkit to do things, the basic thing you want to do first is to start moving your turtle around by a specific number of spaces, or blocks I should say, rather than just once. So we're now ready to start adding some movements to our turtle class. We've just added the clear function. Now if you remember, if you've been following this series, we've already made some left, right, forward, back movements that we could call directly. I'll just put them up on Pastebin for you so that you can see where they are. So we've got, for example, these will all go in the links later on. We've got the turn left and right commands here, which is this one up here. As I say, put them in the description later. And we've also done the ones for doing a forward, backward, up and down in a kind of a general way using the do moves. So again, I'll show you that a little later. So let's pop that one to one side. So this is the left.lua, which is the one where you would just type in, for example, I'll just show you just to remind you. So we go back here, and if I just type in left, let's make it 8 so it gives us plenty of time. Whoops, helps if you type L 8 and then enter, and we'll escape, and you'll see that it's rotating 8 times. So that's basically what we're trying to reproduce in our class. So we can use the code that we've already put into this L.lua, except we're not supplying it with arguments. We just want to use basically what's in here. So what we can do is, if we take that one and copy it, and then we go back to our class turtle tutorial here, and we're going to make a new function. So function, and then it's class turtle, helps if you can spell it properly. There we go, class turtle dot, and then we're going to call this one turn left. And of course, don't forget to put the self in there. And that's the end of the function. And we can now paste in what we just copied. So let's have a look and see what we need to alter here. Now we're not going to have args, we're going to be passing the number of turns. So if we put num turns, that's what we'll be calling from, if you can spell turns properly, that is, num turns. So we don't need to check whether arguments are nil, we can get rid of that. Let's get rid of that. So we've now got a very simple for loop, except we're going to change that to num turns. We don't need that because it's only going to do it in. Okay, get rid of that, we don't need that comment. So we've now got a much reduced set of instructions here. So we're now going to do for turning left, and where we want to enter the number of times that we want to turn left, we're just going to run a simple for loop starting at 1 to the number of turns do, and then I've put this in as a if statement, but there's never a time where the turtle won't turn left. It doesn't need fuel, so I don't think we really need to use the if statement there. So we'll just get rid of that. Get rid of that. We're not that interested in the number of turns at this stage, so we'll get rid of that. There we are. So we've simplified it even more. So we're just doing a simple turtle.turn left for the number of times that you put in here. We want to do something similar for turn right, so let's copy that, paste it down, and this one we're going to call, obviously instead of turn left we're going to call it turn right, and then the only change is here. So we've now got a turtle turn left and a turtle turn right in our class. So we can drop those down a little bit. Let's go back to the one that calls it. So if you remember, all we're doing at the moment using our sort of test function here is to create the turtle here, clear the screen, and then print out my name is, and then thank you for using Survival Toolkit. So it's not actually doing anything at the moment. So later on we'll introduce a menu system so that you can ask the user, well, I'm here, what do you want me to do? And then you could run that menu system to find out. So just for the sort of developmental purposes, we're going to just do a short routine of turning. So rather than putting it in the main function, let's just add a new function here, and I'll call it test moves. Okay, let's just separate that out a bit. We'll keep it nice and tidy. So we don't really need to know what its name is, that's irrelevant. So we're now going to call the test moves, which at the moment of course will do absolutely nothing. So we can now get it to move left or right because that's what we've just programmed in. So in the same way as we did with the t:\clear here, we can do t turn left, and let's do that 6 times. And then we can do the same. Now that has to be a capital T because that's what I've called the turtle object here. So we'll do the same with the T turn right, and we'll do that 5 times so that it ends up at a slightly different place. So if we run this now, that should make it'll check whether our turtle has been labeled properly. It'll check all the libraries are in place. So, and then it will create the object, clear the screen. It won't now print out my name is, and it'll run the test moves, which is what we've just written here. Then it'll say thank you for using Survival Toolkit. So let's save everything here, and if you remember, what we're going to run is the toolkit tutorial lure. So let's get that one out of the way. Back to game. Toolkit tutorial. Hit the enter, and then I'm going to escape from it so we can see what it's doing. Okay, so it's turning that way, and now it's turning that way. So it's done. Success. So we've now made these little test moves to turn right a certain number of times and left a certain number of times by including the turn left and turn right functions in our object class here. So that's great so far, but we now also want it to be able to move forward, back, up and down. And again, if you remember, if you've been watching the series, we did one for, I think it was this one here, which is f.lure for forward.lure, which is a little more complicated, but as we've already written the code, there's really no reason why we shouldn't use it. So just to remind you how that one worked, if we get that out of the way, back to the game, I'm going to rotate that one more to the right because I don't want to destroy anything. It turned right one time, we're now up that direction, so we can make it move forward, say 4 blocks by going forward, let's say 5 blocks, and sure enough it heads off in the direction there. So we want to reproduce that in our class. So if we go back to here. So this is the code that does it. Again, we don't need to check, we're not sending it a bunch of arguments, so that's all already in there. It's this one here, the function do moves. So let's copy that one, and then we can kind of trim it down and do what we want there. So again, this one is in Pastebin for you, which you can use if you're going to create your own turtle class. So this time we're going to do a new function called class turtle do moves. And again, don't forget the self in that. And we'll paste in what we did there. Now we've got I've put the whole function in, which of course we don't really need, but I did it deliberately so that we can see kind of what we're sending it. We don't need to do the do dig, because if you remember, we had the option on, let's go back to it for a moment, forward here, we had the option whether we wanted the turtle to move come what may. So if there was things in the way, it would just dig it and get rid of it. We definitely want to do that in our forward class. If it's going to move forward 5 blocks, it's going to move forward. Whatever's in the way will simply be removed. So we're going to definitely use the do dig, so we don't need that. But we do of course need the direction. So if we copy that, paste it in after self, and then remove the do dig, we don't need that. There we are. Now we can get rid of this spurious function here, and of course we will probably have an extra end statement at the bottom. Yep, we'll get rid of that one. So now our new function, class turtle do moves, self, number of blocks requested, and the direction. We can leave all this as it is. This was what we used on our previous way of doing it. Again, we're choosing which direction we're going, forward or backward, up, down, and reassigning the normal turtle up, down, dig, detect functions to the correct direction. So if our movement is forward, then we use turtle forward, turtle dig, turtle detect, and the equivalents for if we're going up, down. And again, if we're going to go backwards, then we would do the turtle turn right there. Again, we're going to run this loop for the number of blocks requested. We don't really need that. Keep it nice and simple. So it's just a for loop starting at 1, going up to, let's say we wanted to move forward 6 blocks, then we would do this 6 times. We did all this before. The explanation for all this is on one of my earlier videos, so you can look that up for finding out how this works. And then what we're going to be doing is to return the number of blocks moved and any error messages. But basically we've got our overall kind of do moves, which you could call directly from your calling program here, but I would rather we did it so that we still have a turtle forward, a turtle up, a turtle down, so that you can use the functions that you're familiar with already rather than a do moves one. So that's quite easy to do. What we'll do is to put on here a new function, and then again it'll be class turtle dot, and then we're going to call it forward for the first one, self, and end. And then again we want the number of moves, or number of blocks I should say, so we want to go forward 6 blocks. Then what we're going to do in here is simply to call the function that we've already got, this one, control copy, and paste it in here. except this time we're going to put, well, let's call it num blocks requested so that they all match up. There we go. And we know now that the direction, because this is now in our forward one, is going to be forward in a string, because that's the instruction that we're sending. Okay, so when we want to call class turtle forward by a set number of blocks, we in turn call our function that we've already got for the same number of blocks requested in the forward direction. Similarly, we can do the same for the up, down, left and right. So as we're lazy as programmers, we'll copy it, paste it, and then we're going to change that to back, back, copy that twice more, and change this one to up, up, down, and down, which is where it really proves how useful it was to make a kind of a generic do moves, and all you have to do is supply the direction, and then depending whether you've used forward, back, up or down. This just brings me to a point there. At the moment I've just used, because we were calling this originally from the command where we wanted to keep it as simple as possible, we would just put F1. So perhaps we should just change those to match forward or back, and then we've got up, and this would be by default down if the direction equals back, and I think there was one here, yep. So we've now adapted that to suit here. So if we were going to call, if we just go back to our brand new function to test the moves, we now want to go forward 5 times. So we go T forward 5. So how does this work? That T forward 5 would call the class, let's just close these down so that we don't confusing. It'll call the class forward 1 and it will send it 5. This will then in turn call the do moves, sending it 5 and the direction forward. So we go up to do moves, that has now been set to 5 and that has been set to forward. So we checked whether it's forward, yes it is, then the move is turtle.forward, and then it runs this and moves it 5 times. So let's test it all out, save it, go back to this one, we're going to ask it to turn left, turn right and then move forward. Before I run it, I'm just going to check whether that would do any damage. Well, it doesn't matter if it does, it can always be repaired. So let's run that again. So we're going to do the up out toolkit tutorial and hit that, and hopefully it will rotate left and right and then move forward in whichever direction it ends up in. So I'll press enter, escape, so it's turning again, and it's moving forward 5 times. There we are. So we've now made our class do a forward direction. Now because we've already written in T back, let's do that again. Let's do 3. So we're going to move it back 3 times, and then we can do T dot. In fact, what we'll do, I'll do the T up first so that we don't damage any of the stuff that I've already put. So if we go t.up 3 times, then we'll do left, right, forward, back, and then we'll go t.down, and we'll do that twice. So that we should give a test to make sure that it will do up, down, forward, back, left and right. So we'll save all of that, get that out the way. Toolkit tutorial, enter, escape, so it's gone down, rotating. Yep, it's going all over the place. So it's done its job. Not sure whether that, when I watched it, whether it went up as it was supposed to or whether it went down. So let me just make sure that we've got the instructions. So class turtle up. Oop, there we are. That's why that didn't work. It did the down by default. So make sure you've got that right. Down, back. Yep, that should do it. So we'll resave that. Just one small error. Wasn't disaster, thankfully, but it didn't do quite what we were expecting. So this is dangerously near those, but as it's supposed to go up first, we should be all right. Let's try that. Yes, it's going up first, which is great. Rotating, going that way, coming back again, and down. Excellent. So we've got our class working nicely now. Let me just collapse all the that's it. It just makes it look neater if you collapse all these so that you can see. So our class now consists of a generic do moves. We've got then a forward, back, up, down, and a turn left and a turn right. So we're getting on pretty well now with trying to produce our T-go method. So just to remind you what that was all about, in an ideal world we want to be able to put T-go, and in here let's say we wanted to repeat the moves that we've done here but in a single string. So we did up 3, so it would be U3, then we went left 6, then we went right 5, and then we went forward 5, and then we went back 3, and then down 2. Okay, now this won't work at the moment because we haven't written a T-go function, but you can see how rather than doing 1, 2, 3, 4, 5, 6 separate commands, by using t.go and putting up 3 times, left 6 times, right 5 times, forward 5, back 3, down 2, you can make up a very complex pattern of movements, which is how I managed to get my mining program into basically about 40 lines, most of which consisted of these very long commands here. Now it is quite possible for human readability to put each of those commands in separated by a space, just so that you reading them would know, yeah, I'm going to go up 3, then I'm going to do left 6, then so on, and the program will strip out the spaces and just follow the commands. So I think that's going to be our next thing to do, is the go section. I'll just show you what it looks like in its fully functional stage on my finished glass turtle here. If we can find go down here somewhere. I put everything in alphabetical order so that here we go. Now as you can see, the go function is extremely long because there are an awful lot of functions in here, but what I was going to do was to just give you a simplified version where I think that's around 1,000 lines, that one. It's extremely long, but we're going to keep it quite minimal, where we're just going to allow us to go up, down, left, right, and so on. So this will allow us to do things like mining ceilings, kind of cutting out tunnels, placing blocks, placing hoppers, torches, saplings. It's just got a massive amount of stuff which can all be put in here, but that's really the ultimate. We'll go through all this next video when we start setting up the go command. So we'll look forward to getting that done with you.